All right, so today I think we need to start from question number 42. Raise your hand if you already done the remaining MCQ questions. I think only few questions have been 42, 43, 40. Yeah, only around 5. Good. What about Aisha? Have you done the remaining MCQ questions? Okay. Aisha, how about you? Did you try these questions 42 to 46? You should know. Okay, so here in this question, in the diagram shown in the figure, the pulley is light and frictionless, and the force applied on it is capital F. If the frictional force on the block of mass M is simple F, then acceleration of the mass M is. Okay, so the friction acting on this is simple F, and you need to find the acceleration. Okay. So when we pull this pulley, the mass tends to move to this side. So therefore the friction will be in the opposite direction. So that is given simple. And you need to find the acceleration of this mass. Let's mark it as A. If you got the answer, you can share in the chat box. I'll give you a minute. Try to get the answer. Okay. So let's try to get the answer for this. So first I'll mark the tension in the string. Okay, so we can see it's a light string, and also the pulley is smooth. Pulley is light and frictionless. Okay. So therefore, here the tension I mark capital T. Here also tension T. Here also tension T. Here also tension T will be there. Okay, so first I can apply F equals ma for this mass using F equals ma into this direction. So T minus F equals mass times acceleration. So this is equation 1. And then I can consider this pulley, the mass of the pulley. It says the mass is light. So it is light. So okay, so here I can consider this system, okay, or else the pulley, but pulley has no mass, okay, it has no mass, okay. And also one thing that you have to understand, if this mass have a acceleration, okay, if this mass have some acceleration a, the same acceleration will be there for this pulley, right? This one also have the same acceleration. Why? Because if you move this, let's say this is a point on the string and this is the midpoint. And if you move this point to here, what happens? So you actually, so some length x, let's say. So x length of the string has moved here. I mean, some x part will become. So the same time taken will be the same. So therefore velocity will be same, acceleration will be same. So therefore this one also have the same acceleration. But we can't use F equals ma because the pulley is light, because the mass is 0, right? Okay, so let's try to find what we can do. Now we can't consider this one. No? All right, so somehow we want to get another relation with the tension. Okay, so suppose if I assume this one has some mass, let's say some m naught, then if I use F equals ma this direction, capital F minus 2t equals m naught times acceleration. But here m naught is 0, so therefore if the m naught is 0, we get t equals f over 2. Is that right? Okay, let's plug that and see whether we get the similar answer for here. So then since m naught is 0, we get t equals capital F over 2, right? So here you get f minus 2t equals to 0. Therefore, we get t equals 2t equals f. Therefore, t equals f over 2. So we can substitute that here. F over 2 minus f equals mass times acceleration. You multiply m, so a is multiplication, it's take to the other side, it becomes division, so therefore a equals capital F over 2m minus F over m. So therefore the answer is the fourth one. Okay, let's move on to the next question. Two bodies of masses m and 2m move with velocities v and 2v respectively. Equal decelerating forces are applied on both bodies. The ratio of the distance moved by the large mass uh, in coming to rest to the smaller masses in coming to rest is, okay, hold on. The ratio of the distance moved by the larger mass in coming to rest to that of smaller mass in coming to rest. That means the distance moved before it comes to rest of both larger mass and smaller mass, the ratio you have to take. So that ratio they are asking. So these all actually ratios, okay. So for example, here this 8 means it's 8 to 1, which we can write 8 divided by 1, which is 8. Okay. So therefore, I mean, the larger mass moves a distance of, for example, 80 meter, then the smaller mass will move a distance of 10 meter, like that. So try to find the exact ratio. I'll give you a minute. If you already got the answer, you can share it in the chat box. By the way, I'm happy about your dedication because today is 31st night. You could have gone out with your friends or family to spend some pleasure time, but you are sacrificing that moment and studying, joining for this paper class means I really appreciate it. Hirosh, did you get the answer? I think we did a similar question in the last class, but in that case, where we have object move the same distance and gains the same momentum. But here, a different situation, but same way you can think. There's no such answer. Okay, we'll see. Okay. So here two bodies of mass m and 2m move with velocities v and 2v respectively. So these are initial conditions v and 2v. All right. So I'll do this question in two methods. Okay. First, I can use equations of motion. Right. Two bodies of mass m and 2m move with velocities v and 2v respectively. Equal decelerating forces are applied on both bodies. The ratio of the distance moved by the larger mass in coming to rest to that the smaller mass in coming to rest is okay. So first I consider the smaller mass. Let's say, so we have two masses. One is m, the other one is 2m. So I take this as A and B. So first I consider A. Okay. And then I can use P squared equals to U squared plus 2AS. So the final velocity is 0 when it comes to rest. Final velocity is 0. Initial velocity of m is v. Okay, so therefore it will be v squared plus 2 times a times s. So therefore I can subject a now. A is equals to minus v squared over 2s. Now this is minus because it's a deceleration. So I'll take this as A1 because of it's for the A. So A1 is equals minus V squared over 2s. And similarly, I can consider for B. Okay, so V squared is equals to U squared plus 2AS. So final velocity is 0, initial velocity is 2V. So we have to square of 2V. Thank you. 2V squared plus 2 into A, 2 into S. So here we want to take the ratio between the distances. So S1. So this one is 2. And here I can take A2 will be equals to minus 4V squared over 2S2. Okay. And the next thing I can apply F equals MA for both particles A and B. So first again I consider here for A. So using F equals MA, right? So F equals to mass is simple M times A acceleration of this is minus V squared over 2S. Minus V squared over 2S. 2S1. So we have to take it as S1. So then I can take 2FS1, the denominator I multiply to that side. So equals to minus mv squared. Okay, so I'm using this in this direction. Therefore, you can see the force is actually opposite to the direction of the motion. So that's why we get minus. But if we are considering only the magnitude, we can get rid of the minus sign. And then we can write 2fs1 is equals to mv squared. So this is equation 1. And similarly, I can apply F equals ma for B, F equals ma. So the force, the same force, you can see equal decelerating forces. So both experience same force. The mass is 2m times acceleration, A2 is minus 4v squared over 2s2. So then we can take here 2 times F times S2 equals, we consider only the magnitude, so I'm get rid of the minus sign. So here 8mv squared. Okay, so this is equation number 2. Okay, so we want the ratio between larger mass, the distance of larger mass to the smaller mass. So the larger mass means B. So therefore, I have to take the equation 2 divided by 1. Okay, so in the left hand side of B, we have 2f is 2. In the left hand side of equation 1, we have 2f is 1. Here 8mv squared over mv squared. So therefore, here this one cancel. S2 over S1 equals to mv squared cancel. So h. So the ratio, the answer will be the first. You can quickly write this down, take a screenshot and write, and then I will do the second method. Since this is an MCQ, the maximum we can spend 2 minutes, right? So therefore, this is not the method that we have to do this question. So after you writing this, I'll explain you with the other method. Raise your hand if you're done writing. Always take a screenshot and write if there's so much to write. Okay. Okay. Done. So then I will explain the other method. The second method is the best method, and which I'm going to explain now. So here, two bodies of mass m and m move with velocity. They have some kinetic energy. They have some velocity, and then equal decelerating forces. Now, let's say an object is moving in this direction. For example, a car is moving this direction. If you want to bring it to stop, you have to apply a force in the opposite direction of motion. For example, if you hit the brake, the friction force will be acting in the opposite direction to the motion, so that after moving some distances, the car will decelerate and come to rest. Right. So here, what we can use here is we studied in the last class the work energy principle. Right. So the work done by the force. Okay. So F times D is equals to now this. Now here we are not applying the force to increase the kinetic energy, but to decrease the kinetic energy, right? Because when we apply the brake, for example, the friction force will be there. So therefore, it has to do work against the friction, so energy will decrease. So therefore, the work done is equals to decreasing kinetic energy. So the final kinetic energy is zero. So since this is the uh, force is in the other direction, minus F is equals to half mv square. So then again minus and minus cancel. So simply you can think the work done by the force is equals to in decreasing kinetic energy. So the amount of kinetic energy decreased will be half mv square, because initial kinetic energy is half mv square and finally it's zero. Normally we have to take the final condition minus initial condition, but again we are only considering the magnitude, and we are so just we want the change. So therefore we can consider that change work done is equals to decreasing kinetic energy. So first I can consider for the larger mass. So F times the displacement d1 is equals to half into 2m into the velocity of that is 2v squared, and I can use for the other mass, the smaller mass. The forces are equal, so F into S2 equals to half into the mass is m into v square. So I take this as equation 1, this is the equation 2, you divide these two. So F and F cancel, half cancel, v squared cancel, m and m cancel. So here you get 2 squared is 4, 4 into 2, 8. So S1 over S2 is equals to 8. So this way you can quickly get the answer, which is 8, the ratio. If there's anything you didn't understand, please unmute and interrupt. Okay. All right. Do this question, 44. If you got the answer, means you can share in the chat box. Okay, so I'll start the explanation. So here, when we apply this force P, this block tends to move to this side. So therefore, the friction will be acting on this in the opposite direction. Okay, so we can mark that friction as F1. Okay, so when this being pulled to this side, let's say it moves this side, then this rope will move like this. Therefore, the block A being pulled to this side. Okay, the block A being pulled to this side. So therefore, if it tends to move to this side, the friction acting on A will be in this direction, let's say F2. So therefore, equal and opposite reaction force will be there and be F2. Okay. So now we want to find the tension in the string. Okay. So first I consider the system both A and B together. Okay. I consider both A and B as an individual system. For that I am applying figure coefficient of friction between all surfaces in contact is 0.25. The tension in the string is okay. Here we consider this. In the question they haven't mentioned, but we had to consider it's in equilibrium. Okay. Because if I consider it's accelerating, there will be more variable. The additional A variable also will be there. So we had to consider this is in equilibrium. Okay. I think there is a mistake in the question. I mentioned this system is in equilibrium. So then here this being pulled to this side, so therefore friction will be in this direction. So equal and opposite friction will be here. So first I consider this A and B system, and I can consider the force equilibrium. So what are the external forces acting in, I consider in this direction. Okay, so in this direction, what are the forces are there? This P and this P. So P plus P, 2P will come. Okay. And in the opposite direction, and also this F1 also there in this direction plus F1. And then in the left, to the left, we have only the P minus P is equals to, if it's in equilibrium, the net force is 0. Therefore, we can get that 2P equals to uh, P minus F1. Okay. And then I can consider for A, this is A and B, A and B system. This is one. This is equation 1. So you can see we have three variables, T, P, F1. Okay, so therefore we need to write three equations. Okay. So the second equation that I'm going to consider is A. Okay, so if I consider A, I can write by the way, here F1 we can write because they have given the coefficient, friction coefficient, so it will be easier. Yeah. So then here F1 is, we know nu times R. 2P equals P minus nu is 0.25 times the normal reaction force here will be the sum of both the weights. 4 plus 3, 7. Okay. So therefore here I get 2P equals P minus 7 over 4. This is equation number 1. And then I can apply for B. Okay. I can apply for B if equals NA. Because I want to get rid of P, so therefore I can use the force equilibrium of B. So what are the forces acting to the right? E is there, and then F1 and F2. And but P is in the opposite direction to the left, so minus P equal to 0. So from this I can get D plus F1 is nu 1 times R. So nu 1 is 0.25, which is 104. 104 into the normal reaction force is equals to the weight. The total weight is 7. So 4 over 7. Plus here, sorry, 7 over 4. 7/4, and this one will be 3/4. The mass is 3, so here nu is 0.25 into the weight is 3 Newton. Okay, so sorry, it is 4 Newton. The weight of A is 4 Newton, so I can write 4/4 is equals to P. So T plus 11/4 equals P. I can substitute that here. So therefore, 2T is equals to P is T plus 11/4 minus 7/4. So this T and one of the T cancel. Therefore, T equals to 11 minus 7 is 4. 4 divided by 4 equals 1 Newton. So therefore, the answer is 1 Newton. If you consider the block B, the forces acting on it are T is in this direction to the right. The T tension from the string will be there, and then friction F1 is also to the right, and then here the friction also to the right, because this string pulls the A block to the right. So therefore, there will be friction on A in this direction, then equal and opposite reaction friction will be in this direction. Okay, so therefore it is also plus, but only the P is in the opposite direction, it will be minus. Okay, so therefore the answer is 1 Newton. Yeah, so that's what I said. It is in equilibrium, because if I assume this is accelerating, like this is moving this side acceleration, this was moving acceleration, then there will be more variable than the number equations that we can solve. So therefore, system will be unsoluble, not feasible. So therefore, it must be in equilibrium. That's why I mentioned that there is lack something something is lacking with this question. They had to mention it's in equilibrium. All right. Question number 45. A man is on a balance placed inside a lift when the lift is ascending with constant speed of 2 meters per second. The balance reads 40 kilograms. The reading of the balance when the lift is ascending with a constant acceleration of 2 meters per second. Okay. I got an answer, but it's not correct. This is an easy one. No, it's not correct. Yeah, I think so. Okay, so here a man is on a balance placed on inside a lift when the lift is ascending with constant speed. So it is moving with constant speed, therefore forces are balanced. The normal reaction force is equals to weight, R equals mg, and therefore the mass of the man is 40 kilogram. 40 kilogram is the mass of the man. Okay, so then now the lift is ascending, accelerating upward with a constant acceleration of 2 meters per second. In that case, we know R is given by R equals mg plus A. Okay, so therefore R equals mg is, we know it is 400 plus m into A, 40 into 280. So R equals 480. So this scale is calibrated with mass. So therefore you divide by G, divide by 10. So 48 is the answer. Okay. Since here you get R is 480 Newton, but the scale is calibrated with uh, balance is calibrated with masses. So you have to divide by 10. So it will be 48 kilogram. And by the way, by now you should know what is the equation if the lift is accelerating upward, what is the equation when it accelerating downward or decelerating upward. These things by now you should know. You don't have to write the equation, I mean apply F equals ma and find. Okay. එහෙම කරනවා නම් ඒකේ තේරුම හරියට ඉගෙන ගන්න නැහැ කියන එක තමයි. Okay. So by now you should know if it's moving constant acceleration upward means this is the equation. Okay. If it's decelerating upward means then R equals m g minus A is decelerating vertically upward. Okay, and accelerating vertically downward R equals m g minus A, accelerating vertically downward. Okay, so these things without, I mean, you should be able to state okay. All right, so let's move on to the next question. And I'll tell you again. So when I'm explaining these questions, I'll assume you have the complete knowledge. Okay. If in case certain thing that you didn't understand, then please don't hesitate to let me know so that I can explain. Okay. Because doing paper class, what we want is to, I mean, thorough your knowledge. So if that is not happening there means it's pointless joining to this class. So if there's anything that you didn't understand, then let me know. Yeah, Hiroshi, that's correct. If the lift is accelerating downward, it is mg minus A. Okay, mg minus A. R equals mg minus A. If it's accelerating upward, then mg plus A. We know when A equals to G, when lift is accelerating downward, if A equals to G, that means if the lift accelerates with the gravitational acceleration, then you can see the r will goes to 0. So whoever inside the lift, they feel like they will be floating. Okay, do this question. I think such a question we did earlier. So this is not a complicated question. This is a very basic question. Only they are checking your understanding of the forces. Okay, I think I got the answer from Dinujaya, and it's correct. Also from Hirosh. Your answers are correct. Okay, a horizontal force of 12 Newton is pressing block of weight 5 Newton against a rough vertical wall as shown in the figure. Okay. If the block remains at rest, the magnitude of the force acted upon by the wall is. Okay, so here the weight acts vertically downward. Okay, 5 Newton. And if it's in equilibrium, means there must be a equal and opposite force, vertical force. So that is actually the friction. So the friction acting on this is 5 Newton. Okay. Okay. So here they are asking if the block remains at rest. So if it's in equilibrium, magnitude of the force acted upon the block, by the wall. So by the wall, we have a friction force of 5 Newton and also the normal reaction force 12 Newton, right? So this 12 Newton and this 12 Newton equal and opposite. So in horizontal direction also it's in equilibrium. Okay, so then the magnitude of the force acted upon. Now from the wall, there are two forces, 5 Newton and 12 Newton. And the resultant is, these two are perpendicular forces. So therefore the resultant is 5 squared plus 12 squared square root. Okay, now you should be have a good knowledge of Pythagoras triplet. 12, 5 anitheka 13, right? So don't try to spend writing this 5 squared is 25 and 12 squared is 144. Adding these two, we have 169 square root. If you are doing these, still doing these things in your A level, means you are wasting your time. Okay, 5, 12 now, the other one hypotenuse will be 13. Okay. So if you have such issues, please correct it now. You have to this. Okay. All right. Okay. 47. Okay, I think two more questions. Okay. Do question number 47. Okay, we'll check. So I got different answers here. Okay. A carriage of a train of mass 5 m is at rest on a smooth railway track. An engine of mass 3 m moving with a speed of 8 meters per second collides with the carriage and gets coupled with it. The speed of the combination coupling is after coupling is okay. So this is a easy one, right? Momentum conservation. Total momentum before the collision equals after the collision. So here 5m is rest. Okay, so 5m into 0 plus the engine 3m into 8 is equal to 5 plus 3. So the total weight of the system is now 8m into the speed. Let's say v is 0. So here 8m cancel. So v equals 3 meters per second. So it's an easy one. By the way, Dinesh, you can text to the Knowledge Institute. As it will be easier for me to view on my PC than the mobile device. Okay. 48. A box of mass 6 kilograms slips on ice with speed 9 meters per second. Okay. A body of mass 12 kilograms falls vertically into it. The speed of the box now. That is also a very easy question. It will take maximum 5 seconds. Anyone got the answer? Okay. Just so we'll see. All right. So here, wait. So okay. So this one has a speed of 9 meters per second. I mean, in your exam, no need to draw these things and all. Okay. Mass 6. Okay, and this one has a mass 12 kilogram. Simply, you can write the momentum conservation. So 6 into 9 equals 12 into So 12 plus 6, 18 into V. Okay, so 6 into 1, 6 into 3. So V equals 3. Amira's answer is correct, 3 meters per second. Because this is dropped vertically, so it doesn't have any momentum in the horizontal direction. So we can consider the momentum conservation in the horizontal direction before falling onto it and after. So before, only this one has a momentum of 6 into 9. So after that, this one has no momentum, right, in the horizontal direction. 12 into 0. Can only write that as well. So equals to the momentum after. So total mass is now 12 plus 6, 18 into, it will go with the common speed. So then 6 into 1, 6 into 3, 3 into 1, 3 into 3, V equals 3 meters per second. Okay. So when you read this question, only thing you write 6 into 9 equals 12 plus 6, 18 into V. That's all. So therefore, we get V equals 3. So those question on maximum 10 seconds. Okay. Right. Question number 49. I got two answers from two students, but both are different. I got three answers. Three of them are different. So one says 200, the other one says 250, and the other one says 300. Let's see which one is correct. A bomb moving horizontally with speed of 100 km. Okay. Explodes suddenly into two pieces of mass in the ratio 1 to 2. So I consider the momentum conservation in the vertical direction. Okay. So initially 0, the vertical direction is equals to, so 400 into smaller piece into 400 into 1 minus the mass ratio is 1 to 2. Okay, so I take 400 into 1 equals to, so V into 2. That means if this one's speed is 10, this one's speed is 20. So no need to write, you can just take 1 to 2 because divide if you take to the other side. So therefore we have V equals to 200. So the first one is correct. Okay. Okay, I'll ask you further. It's another question based on this same question. What is the velocity of larger piece? What is the velocity of larger piece? Okay, wait. I am not done. Okay. Here, actually, they are asking the speed of the other piece will be. So the other piece, then they're asking the speed. No, I confuse. I considered as the speed in the vertical direction of the other piece. No. So we want to take the overall speed. So therefore, this is actually, I have considered the vertical component. Okay, wait, I'll do this question again. Okay. I think the answer is not the first one then. It will change. So here the mass is moving, let's say the mass is 3 kilogram, for example, or 3 n, because the ratio 1 to 2, so 1 plus 2 is 3. So therefore you can consider either 1 kilogram or 3 kilogram or 3 n. I consider as 3 n. Okay, so then after explosion, this before explosion, it is moving this direction with the speed of 100 kilometer per hour. So the after explosion, this one smaller one has vertically upward 400 kilometer per hour. Okay, and also it has some horizontal velocity as well. We don't know. It might have. But it says the smaller piece begins to move vertically. So it have only, okay. So therefore it has only 400. So if you take the larger mass, this is 1 m, 1 m, and then this is 2 m. So this one has speed. So in vertical direction, momentum has to be conserved. 400 into 1 means 2 into 200. And also this momentum should be there. 100 into 3, 300. So therefore this one should move with the velocity 300. Okay. Okay, hold on. 3 into 100, 300. So 2 into 150. Yes. 2 into 150. Okay, so 150, 20. So therefore this is 250. The answer is second one. Now again, you don't need to do the calculation for Pythagoras theorem. Pythagoras Dandepa, this is a Pythagoras triplet. 15, 20. So therefore this one will be 25. Or else I know, but I realize considering this 1.5 and this is 2, then this will be 2.5 because 1.5 is 3 divided by 2 and then 2 is 4 divided by 2. Therefore 5 divided by 2 is 2.5, then the proportion 250 should come. Okay. Right. So therefore the answer is 250 speeds. So the very important thing is we have to read the question carefully and we have to understand it carefully. Now, at the first glance, I was thinking like they're asking the vertical speed of the smaller particle, right? That is my misunderstanding. but it says the speed. That means you have to consider the overall speed of the larger mass. Okay. If in case you guys, if one of you are not thorough with Pythagoras triplet, what you can do is take half an hour of time, do small research. So you don't have to search all the books and create 10 textbook. You have this AI, Chat GPT. So you can give ask the Chat GPT to give Pythagoras triplets. So there are various groups are there, like 3, 4, 5 is one group, and likewise 12, 5, 13 is another group of Pythagoras triplets are there. So if you want, you just take half an hour time and spend, so that it will helpful for you to do. I mean, otherwise you have to take this square plus this square plus square root. It will waste your time in the exam, right? So if in case you are very well thorough with these Pythagoras triplets, then you can quickly get the answers. All right, do the 50th question. I think here it should be 3v cos theta. So this question is also very easy one. Maximum you can spend 30 seconds. Speed means the magnitude of the velocity. For example, you can think like that. Yeah, in the previous question also. Okay. Yeah. So speed means the magnitude of the velocity, no? So you can see after the explosion, this one has a velocity in downward 200, right? So this is the horizontal component, sorry, vertical component. The horizontal component is 150. Then the resultant velocity, how do you find? Velocity is defined as Vx squared plus Vy squared square root. So this is V. So its magnitude, if you consider the magnitude of that, it is the speed.
No,
Okay.
I understood that. I'm asking if one particle went vertical, how do you think the other particle won't go vertical?
Yeah, now here, after the explosion, this they are saying this particle is moving upward with this velocity now, right?
Yes.
Okay, that speed. Okay, now if we consider before the explosion, Is there any speed in the vertical direction?
No.
No, therefore the momentum in the vertical direction is zero. So
Yes.
therefore the total momentum in the vertical direction should be zero. So 400 into 1, therefore this one has to be 2 into 200 because the mass ratio is 1 to 2. So this 1 into 400 is 400. So therefore this one should be 200. So you understand that one, right?
Yeah. But the
Okay.
direction.
And yeah, the direction is vertically downward because it has to be equal and opposite. No, then only it will be zero.
Okay.
Resultant has to be zero, no? Because
Yes.
initially the total momentum is zero. So here again the total momentum has to be zero. So it has to be equal and opposite. So
Mm.
the net moment in the momentum in the vertical direction is zero.
Okay.
Okay. And then here it has initially horizontal direction. Momentum is 300. So this one has no any velocity component. So 2 into here 150 will be 300. Okay.
Mm.
Okay. Okay. By the way, anyone finished the 50th question? I didn't get any answer yet. Okay, fine. So a shell is fired upward with an angle theta with the horizontal with velocity v at the highest point. Now we know the horizontal component is v cos theta. So at the highest point, the vertical component is zero. So total velocity is actually v cos theta, right? So only that velocity is there at the maximum height. And also I consider the mass of this particle is 2 kilogram. Okay. So after that, what happens? It's exploded into two equal pieces, 1 kilogram, 1 kilogram. Okay. One piece move along the original path of the shell again. So this one will move in the original path. One piece moves along the original path of the shell again. Okay, so that means it is okay. So you can see initially 2v cos theta is equals to now 1v cos theta and then the other one. So I'm considering this direction. So this is before the explosion. So after the explosion, 1 into v cos theta and the other one, the speed of the other piece immediately after the explosion. That also must be in the same direction, 1 into v cos theta. So it has to be fourth one, 1 into v cos theta. That's all. So both will go in the same, after the explosion, both will fall at the same range. Yes, shell is fired is V. So that means here making angle V and then, sorry, the initial velocity is V, making angle theta. So this component V cos theta and this component V sin theta. So at the maximum height, we know at the projectile motion at the maximum height, the vertical component will be zero, only the horizontal component, sorry, uh, okay, at the maximum height, only the horizontal component will be there because theta. So I assume the mass is 2 kilograms, so momentum is 2v. So it divides into equal masses. So 1v cos theta, 1v cos theta. So answer is v cos theta. Okay, right? Yeah, you can take same thing. Then you get the same answer. If you would consider as initially mass is m, so momentum is mv cos theta. So after that, the mass divided as m over 2, then the velocity is, you can see it will be 2v cos theta. Hold on. Yeah, if we take as m, v cos theta, the piece moves along the original path of the shell again. Okay, so yeah, and then the other one also should be m over 2. They are equal masses, divides into equal masses, and something's went wrong with. If I consider v, hold on. So I consider my example again, 2v cos theta. Okay, after that the mass is 1. It will move in the same direction, so it will be v cos theta and plus v cos theta. So both will have v cos theta, v cos theta. So then here m over 2 into 2v cos theta. The speed of the other piece immediately after the explosion. So if we take as m over 2, sorry, here, this 2 won't come. Negative. Nice, correct, yeah. So here, m over 2 v cos theta, m over 2 v cos theta. So if you add, total momentum will be there. Okay. Yeah, so it has to be v cos theta again. Right? Now imagine if you throw a mass, okay? Let's say mass is capital M, and it is divided into two equal masses, M, or else I take 2m mass, so it will be easy for you to visualize. So 2m mass, if it's and moving with the speed v, okay, and then if they break into equal masses, okay, so then to keep the momentum constant, they both will go with the same velocity, okay. It is like, for example, what can I say? Hold on. For example, let's say two cars, not cars, maybe two spaceships are attached, moving with same speed, and then they are just making the connection. They are disconnecting. That's all. Let's say two cars or spacecraft. They are attached by a small cable, and then the explosion is something like they are detaching the cable. It will keep moving with the same speed. You understand? If there's anything that you didn't understand, please let me know. All right. Question number 51. In the above problem, if the shell did not explode, its horizontal range would be r. If so, what would be the distance between the 2 points where the exploded piece landed on this occasion is? In the above problem, if the shell did not explode, its horizontal range would be r. If so, what would be the distance between the 2 points where the exploded piece landed? I think, hold on, in this question, two pieces of equal mass, one piece move along the original path. Yeah, so I think this question is wrong. Here we have to have 0. The distance both will be when it's at the maximum height, if they explode into equal mass. Okay, so to maintain the just right after the explosion, okay, right after the explosion, to maintain the same momentum, both will have the same velocity. Okay, so then it will fall in the same uh, places. So therefore, the distance between those two will be 0. So you can take and change one of this as 0. Now, I mean, if the shell did not explode, means like without explosion, like for example, if you throw this 2 kg mass, it will go in this parabolic path, right? And it falls here. So this is the range. If that is not didn't explode, but fortunately, it was exploded at the maximum height. But if in case if it's exploded somewhere here, so then also if it's, yeah, since it's exploded into equal masses, it will fall in the same place only. Okay. Okay. Let's do the part 2 type questions. Okay, do this question. By the way, in this question, now here it says equal mass. Now, what if the mass is like the ratio like 1 to 2, 1 to 3, like that? So the equal mass conditions, the less chance they will give you such a question in a paper. So now instead of equal masses, assume what will happen, because those cases also you should have to study. The mass divides into, for example, let's say 1 to 2 ratio, right? So let's say you can consider the total mass is 3 kilogram, and then it has divided into 1 kilogram and 2 kilogram. In this case, what would happen to these masses? Also, let's say they have exploded at the maximum height. Okay, so if that's the case, then what would happen to its velocity and then the point of their landing on the ground? Let's discuss that. Now this is the range. Let's say this is c equals 0. and then here x equals r. So it will be the range if that is didn't explode. Now let's say at the maximum height it is exploded into two masses with ratio 1 to 2. Okay, so in that case what would happen? And they also have to give in the question like at least one of the velocity after the explosion, otherwise can't do. Let's say this one is moving with the speed of 2v after the explosion. The larger one is moving with, say, yeah. So let's consider this one is the larger mass and the small mass. So this one has speed after the explosion, let's say 2v, and this one you need to find, let's say as w. So if the particles have equal masses after they explode, the range will be equal to the initial range if it didn't explode. Yeah. Because if you consider if it explode into two equal masses, okay, then to maintain the equal momentum. Now, for example, let's say mass is moving with the speed mass capital 2m, and let's say velocity v. Okay, so the momentum before explosion it will be 2mv. Okay, and then after if it's if it's explode into two equal mass m plus m, so what are the values that you can put for x and y so that this summation is equals to uh, this 2v. So m is common now, so we take here m out, so here it will be 2v, then we have x plus y. Okay. Okay, so actually it is not necessarily the same velocities. Yes. So because here we can x plus y can be equals to 2v. So we can input uh, for x the range 0 to 2v or even greater than that, because if in case y is moving backwards. But here since in this question it says the one piece moves along in the original path. So therefore original path I think in this question is not complete. Okay, so here keep in mind it is not necessarily both will move with the same speed after the explosion. Okay, they can have different values. Okay, so you can see we can put different values. Now, for example, if x is, let's say I'll take v is some value like 10. So this will be 20 now. If I take 10, then 2 will be 20. Then how can we get 20? So 5 plus 15, 4 plus 13. So infinitely many solutions are there. And also you can come up with negative answers also. That means one after the explosion, one is more exploding to the back, opposite direction. Now, for example, x can be minus 5 and y can be plus 25. So again it will be 20, right? So therefore there are infinitely many solutions, but I think this question is not complete, I guess. I think at least they had to give the value of the speed with the same speed or something. One piece. Uh, Hirosh, if you have this question, can you check whether this question is complete? I think we have taken this question from that book actually. Okay, by the way, in our next class, I will do a complete analysis of these type of question. Okay. And also, there is something that we can do, like after the explosion, where will be land, and this one where will be land. And to solve that type of question, we consider the center of mass of these two masses. Now, even, for example, here, let's say the values are not accurate, just for to get some idea, intuition. Let's say after explosion, this one has larger speed and this one has backward some speed. So initially it has at the maximum it will be v cos theta, something like that. But here this one has larger speed and this one has some smaller speed, and this one will land somewhere here, and then this one will land somewhere here. But the center of mass is always follows this, something like that. I will take a complete analysis of this particular scenario in our next class. Okay. Okay. So for the moment, we'll skip that and let's do this question. Okay, a balloon rising vertically has a velocity of 5 meters per second when it is at a height of 20 meters above the ground. A small object is released from the. Okay, see you then. Take care. Bye. A balloon rising vertically has a velocity of 5 meters per second when it is at a height of 20 meters above the ground. A small object is released from the balloon at this instant. Find the position and the velocity of the object after 1 second and 2 seconds of its release from the balloon. After how much time from the release will the object strike the ground? With what velocity will it strike the ground? Okay. I hope you have answered at least half of the questions. A small object is released from the balloon at this instant. So it's released. So when it released, this has an initial velocity of 5 meters per second vertically upward. Okay. Because everything inside the balloon will already attain this speed. So if you drop this, it will have the initial velocity of 5 meters per second vertically upward. Find the position and the velocity of the object after 1 second and 2 seconds of its release from the balloon. So it is easy, What we can do, we have to apply vertically upward. S equals ut plus half at squared. So the displacement after 1 second I'll take as S1, 5 into 1. So I'm okay, plus half into acceleration is minus 10, because gravitation acceleration is downward. I'm using the equation upward into time 1 squared. Therefore, S1 is equals to 5 minus 5. So S1 is equals to 0, which means It's actually after 1 second goes up and comes to here to the same height. So find the position of the positions and the velocities of the objects after 1 second and 2 seconds. So the position therefore 20 meters from the ground. So then velocity we can use v equals u plus at. So that one I use downward because I can now I already understood that this is falling. Actually, it might have went up and so velocity will be downward. Okay. So then I can write v1 equals initial velocity is minus 5 because it's upward plus acceleration is 10 in 1. So therefore v1 is equals to 5 meters per second. Okay, and then after 2 seconds, so this after 1 second. So after 2 seconds. Again, simply I can use s equals ut plus half at squared. So I'm using downward because I know after 1 second it has this much, or else you can do upward and you get a minus value. If you consider upward and did the question, you will get a minus value, so that which means it will be downward positive value. Anyway, so I take downward as 2 equals, so it's minus 5 because it's vertically upward into 2 plus half into 10 into 2 squared is 4. 2 into 1, 2 into 2. So S2 equals minus 10 plus 20. Yeah. 10 into 220, so S2 is equals to 10 meters. Okay. And the velocity, we can use downward, v equals u plus at. v2 equals minus 5 plus 10 into 2. So v2 equals 15 meters per second. Now, actually, you don't need to write this equation. So we know every second the velocity will increase downward. No, increases by 10 meters per second. After 1 second, it's 5 now. After another second, it will be 15 because every second the velocity will increases by 10 meters per second because the acceleration is 10 meters per second divided by 1 second. No, the rate of change of velocity. So every second the velocity will increases by 1 second. All right. Okay. After how much time from the release will the object strike the ground? Okay, so for that we can. So if you are done writing this, I can erase this. I assume you are done. So then I can use downward s equals ut plus half at squared. So if it's striking the ground means net vertical displacement is 20 in downward. Initial velocity is 5 into time. We don't know. Let's take that time is something like p equals capital T. Plus half into a is 10 into x time t capital T square. So I can divide by 5. So here 4 equals minus t plus here 10 divided by 2 is 5, 5 divided by 5 is 1 t squared. So therefore 0 equals t squared minus t plus 4. So we want to factorize this. 4 we can factorize as, okay, so we get square root terms. Okay. So I use the formula t equals minus b. Minus into minus 1 is plus 1. Plus or minus 1 squared is 1 minus 4 into a is 1 into something went wrong. 20 equals minus 5t plus half into 10 into t square. So here dividing by 5, 4 minus 1, 2, and then 2 divided by 2 is 1. So okay, if you take the 4 to the side, it becomes minus 4. Okay, yeah, now it makes sense. So into minus 4. So therefore t equals plus 1 no minus 1 plus 16 square root of 17 over divide by 2a, 2 into 1, 2. So divide by 2. So the square root of 17 is greater than 1. So we can't consider the negative solution. It means like backward in time. So we only consider the forward in time solution. So therefore we have to consider plus. So we consider under the plus case. So t is equals to 1 plus square root of 17. If I'm correct, it will be 4.08 or 7. Let's check. Oh, square. Sorry, I want 17 square. 17 square root. Adam, I have told you no when I'm doing class.
Can't change laptop.
What?
Laptop.
What happened to the laptop?
And then I can look like this.
Okay, I'll seek help from someone else. Go. I'm busy here. Okay, I'll be back in 15 minutes. Bye. So, sorry, 4.12. Okay. So it'll take roughly 4.1. Not bad, my guessing is. So 4.1 over 2. So t equals 5.1 divided by 2. So it will be 2.5 2.55 seconds. Okay. Yeah, close to 2.56.
So the last formula you used to find t, can we use another method?
Instead of this,
Yeah.
okay, so this is solving quadratic equations. Now you have studied in your syllabus. There are 4 methods to solve a quadratic equations. What are those 4 methods? One is factorizing, but here we can't factorize this because you can see we get square root of 17. So the normal factorization is different. Second thing is completing the square. So you can complete the square method. So completing square method is like this. So 0 is equals to here t square minus t minus 4. So we write t, it is minus half of this coefficient 1 over 2, and then you square it and then subtract the square of this. 1 square is 1, 2 square is 4, and then we have another minus 4 term. So 0 equals t minus half square minus, here we will get 4 into 4, 17, and 16 plus 1, 17 over 4. Okay, and then you take the square root and square this, right? and then you can write as factors of two squares, difference of two squares. So this is completing the square method. And third method is using the formula. Formula is, x equals minus b plus or minus b squared minus 4ac over 2a. By the way, I'm holding like this, it feels weird to me. Okay. Yeah. All right. And then the fourth method is drawing the graph. You can draw the graph of this function t squared. So you can take the function of y or gt is equals to t squared minus t minus 4, and then you plot the graph. So it has a minimum, and then so the graph has minimum, 2 points intersect the x-axis. So these are the solutions for where the function is equals to 0. Okay. So out of these 4 methods, in which method you can get the answer effectively, you can use that method. Okay, now suppose something like this, t squared minus plus 5t minus 6, then you can factorize easily. So no, wait. Plus t minus 6, okay. So if something like this, then you can easily factorize. So t minus 2, t plus 3. Okay. All right. And also we want to find the velocity it will strike the ground. But now I know the the time. The time is 2.55 seconds. Okay. So then we can use vertically downward v equals u plus at. So final velocity is v downward, initial to minus 5 plus 10 into 2.5. So you get this value 20.6. Okay. And we have more questions on this. So all these questions, the remaining ones, you can do it as homework at home. And if you find anything that you want to discuss, let me know the question number, because I'm not going to discuss all the questions here, but you have to do all these questions because I can't do everything. Okay. So here you have to do all these questions, but if you find any certain questions is hard, you can circle it 11 and let's say for example 11 and 13, then you can mention that question. I want to discuss these two questions, so you can put it in the group. So it will be better if everyone put it in the group, then it will be everything will be there and I can see what are the questions I have to discuss, Kera. Okay, so please do all these questions, and also I will try to send another set of questions based on the other lessons. Okay, so maybe I can, I will check and share you another paper to do. All right. So by the way, the next week class will be as usual time, Tuesday 8:30 p.m. Okay, 8:30 to 10:30. All right. So anything else regarding the class or any concerns? For me, I feel hungry. I want to go and eat. Okay, then for everyone, advance Happy New Year. Thank you, Hirosh. Start your new year with studying. So I prefer you to study till 12:30. Okay, bye. Good night. And please study physics, not other subjects. Okay, please study physics. Okay, start your year with physics. Okay, bye, good night. Fi amanillah.